My name is Charles Baer. I'm a solution architect here based in this office. So I have a talk to give on some serverless and AI ML solutions we have. One that I've developed, another one that we have developed jointly here as a part of Google Cloud for a solution. All right. Cool, we should be good to go.
Wait for it. Sometimes there it is.
All right, we're good to go.
Perfect.
Okay, so that's what I said, serverless, AI, and ML. So the first one is a project that I worked on recently, and this is, there's a trade-off when you're looking to build or to make use of some AI and ML as a part of your application. And the point of this project was to make it easy for one of our customers to be able to ingest a whole series of different audio files. And these were long audio files. They had a platform that they would accept audio files from, and they weren't able to categorize these in an intelligent way. Or they could categorize a subset of them, or they relied on their users to categorize them for them. So it wasn't optimal for them. And so we came up with a solution here that was pretty interesting. So the main problem here, again, they've got a website. They allow users to upload any of their data, any of their audio files. And for example, these could be things like podcasts. And then those content would be prioritized and categorized in different ways, tagged, make it easier to surface and for other people to find. So this is kind of the main point of it here. Now the problem with this is that they essentially allowed users to do that. So the content could have been not properly tagged when somebody uploaded it. It may be improperly, inadvertently or maliciously tagged in different ways. And then you're relying essentially on your users to be able to find that for you. So this wasn't an ideal situation for them. But it's also not an easy problem to solve, right? Because in order to do this, you would have to then go through and process all the audio. You could either listen to it, or you could process it somehow. You could write your own machine learning algorithm to go and process that data and translate that audio file into text and then do some things with it. And essentially, there's a couple problems with this. You can imagine if you operate any kind of site at scale, you're going to have a lot of different requests. You're not just going to have one or two uploads. You're going to have thousands, potentially hundreds of thousands, depending on the popularity of your site. This particular customer had a pretty big problem with scale. They had a lot of audio submissions. So you need to be able to do this at scale. The second one is performance. You need to be able to do this relatively quickly, or you need to be able to decouple this so you have a whole queue of different files that you're going through, and you're able to do the transcription and categorize them appropriately. So how do you do this at scale and while still having good performance with your system? That was the other challenge. And the last one is, the audio format itself is not necessarily conducive. You don't have a simple way of understanding. You have to do a significant amount of translation from the actual hertz that are recorded and the way that's represented in an audio file to actually think about categorizing that. And that's because there's essentially two steps. You have to convert that to text, understand what kind of text that would be, the context of the text, and then make a decision based on that point on the categorization and what specific action you would take. So those are the main problems to solve that I had working with this customer. I came with this reference architecture, fancy serverless reference architecture. But the main point here is, if we sort of walk through this, we made use of a couple of machine learning APIs that Google provides. And one of those is our speech to text. So this is should be pretty straightforward. With speech to text, it takes in either an audio file, or it could be you can actually stream in real time the audio back and forth and get responses. But it'll take that audio file and convert it to text. So it seems like a relatively straightforward thing to do. This is something that, as a developer, you could decide to do it yourself. And there are some benefits from doing it yourself. For example, if you are working in a problem or a domain space where you have very specific jargon or very specific terminology that means a certain thing. So for example, financial services might be one of those, where if your recording has very specific terms that mean something really only to your domain, you may actually want to build your own model, because your audio model may or may not, or the speech-to-text API may or may not pick that up. In this case, we're essentially mostly focused on podcasts and things like that, which are essentially relatively straightforward. We can make some assumptions about not being in a specific business domain. So for that case, we decided to save a lot of time and energy of actually developing our own model by able to just using the API. And it's really straightforward API. You send in an audio file, and essentially over time, it will go through that audio file and then return to you a set of text, which is contained in the audio file. Built into the platform in that API is the ability to essentially handle that long-running kind of polling for your application. So for us, that made a really good case for using that, because we didn't have a specific reason to develop our own. So for us, performance, scalability, and our ability to meet the requirements were well suited to use the speech to text. The other one is our natural language processing. So essentially, if you take that text that you've converted now, how do you categorize that, pull out entities or sentiment analysis from that? So again, you're faced with the same choice. You can actually build your own, and you could build something like this with TensorFlow. There's a couple of open source ones you could make use of as well. So you use someone else, use transfer learning to train the last bit, and use that as a part of your API. For our purposes, what we wanted to do is pull out entities as a way to help categorize, as well as sentiment, whether it's positive, negative, or sentiment relative to individual entities. So our cloud NLP API provides that for us, made it really straightforward as an option to use. So again, we decided to use this. Again, our requirements were scalability, performance, and being able to meet the business case. And so we made use of that as well. A couple other things that are worth noting, and then I'll sort of walk through this. The glue that stitches this all together is essentially an asynchronous type of cloud function. So cloud functions are asynchronous type of, is very good for building an asynchronous event-driven type of platform, because it decouples the real-time, the synchronous requirements from an application and allows it to be driven by specific events. In this case, because we stitched several different APIs together, when the results of those APIs became available or were scheduled otherwise, we went through and we were able to check. And so that actually helps from a scalability perspective, because we can scale up the number of cloud functions we have. If we have a large load, it will automatically scale to do that. It also allows to scale down when we don't have a large load as well. So it doesn't require constant running, so therefore we can reduce our costs as well as usage. So just spending a minute walking through the architecture. So we have audio files, obviously, and this is sort of the step one. Somebody uploads an audio file, and this could be as a part of any of your process. But in our case, we essentially assumed that was the entry point. We would upload it to our cloud storage, and that would be the beginning of our business process here. So step number two, we have kind of a handy function within cloud storage that if you put something into a given bucket in cloud storage, it will kick off a trigger, and that trigger allows you to then notice and take action on that trigger. So our cloud function is also triggered by that file that's been placed in there. So every time a file is placed in there, user has uploaded their file is placed as a part of this process, it'll kick off this cloud function. This cloud function will then go from 3 to number 4 and actually call the speech-to-text API. So we take that file, send it to the speech-to-text API. It's going to return a job ID, because again, we're sending in a file, so it's going to give me a job ID which I can check over time. What we did here in number 5, 6, and 7 is essentially, once we got that speech-to-text job ID, we thought, okay, we need to keep checking on that. So we would publish it to PubSub. And PubSub is another part of the event-driven architecture, which allows you to essentially build at scale. Because PubSub, you can send individual messages and then other computing components like cloud functions or really many of the other components of the platform can listen to those messages as well. So when we publish that message, whatever's listening to or whatever's in that queue will then be triggered. So what we did is we published that job ID once we got it from the speech-to-text API, published that job ID. And then every 10 minutes, and when this is configurable, of course, we have something called a Cloud Scheduler. It just kicks off very simple PubSub message or will invoke one of your actions. The main point of this is that all of those job IDs that sort of get aggregated here from 10 minutes or so in number 5 are then essentially picked up because the Cloud Scheduler will trigger another cloud function in number 7. So So essentially, that Cloud Function will check with the speech-to-text API and say, hey, are you done with my results? Do you have my translation for me yet? If it does, then what we do is we store those results here in number 8. And then what we'll do is trigger 2 more Cloud Functions. And because, again, we're storing a file in cloud storage, you can use those handy triggers. So we use a trigger here to kick off the NLP API. So in using our NLP API, super straightforward, we grab the entities within the speech-to-text. So all of the person, places, and things that are within that text, we have access to those. We also have access to the sentiment relative to those individual items, or the sentiment in general for the entire the audio component. The other thing that we did, we wanted to do, was use something called the Perspective API, and this would essentially decide whether or not the components or the text that we're sending in is toxic to conversations. This is something that it's been jointly developed and Google has contributed to from a YouTube perspective as well. It's a third-party API, but again, it just shows you a way that you can integrate your process to then look at the content you have. Is there something that is super negative in this discussion or in this podcast that you may want to either tag or otherwise know about? So when we put that file in there, it'll trigger both of those Cloud Functions. Those Cloud Functions call the APIs and then essentially store the results in cloud storage. And then we put a very simple UI, which is App Engine. App Engine is our essentially platform as a service. Great for running super scalable or even simple web apps. You just write the code and deploy it. So we essentially build a front end around that. So this is essentially the reference architecture here. And I can spend a minute. Are there any questions on the architecture before we move forward? I've been talking for a few minutes. Let's see if anyone's here. All right. OK. Well, I can go through a quick demo of it here. Well, we'll see if I can go through a quick demo. I should go through a quick demo. OK. So again, this is, let's see if I can make this a little bit bigger here. There we go. A little bit better. Yeah. All right. A little bit better. This is a very super simple UI. Essentially lists a series of files that we've uploaded. And then based on the results of those files, and again, we ran through this previously because with the speech-to-text API, it takes about half of the time of the actual audio length to actually process. So I didn't want to do this live. But we have the results here from the conversion. Let's see if we can load it here. There we go. OK. So again, super simple API. We have both a full transcript. So this is the entire text that we got back. And then if these are essentially rating the types of comments and the individual comments. And so you see these are all green in the case that none of them really, from a negativity perspective, provide us any indication that they would be a negative comment. What is interesting here, though, is that when you click on the individual kind of component that is highlighted here, this is provided by the speech-to-text API. It gives you this is the information that we get from the Perspective API. It also gives you the start and end time, which is super helpful if you want to go back and be able to look at that individual content. And then from the NLP perspective, it gives you a really nice sense of which entities are actually in this individual subtext. So you can see some of the things that it pulled out of here. Some of them are useful, some of them are not so useful. But it also gives you then a sort of a sentiment. So if you look at the color coding up here, it'll give you a sentiment, and you can use these for categorization, right? Because these are essentially the types of labels you can use to actually categorize that content that you have. So we, again, built the UI just to surface those in individual components. You could build these into the tagging if you were actually building a website. OK. All right, so that's it for the demo. Any questions on this particular architecture or the components itself, the AI platform? If not, I have one more section to go through as well. Go through that. All right, good. OK, so this is a different solution. So the previous one is something that I wrote with one of our customers and our professional services team. This one is actually a solution that has been broadly put together by the product team. It combines a couple of different technologies for a very specific applied use case. Context Center API And the point of this one is that I think you've probably all had some experience with the contact center, either via chatbot or via calling with your phone. And oftentimes those experiences don't go terribly well. You have to repeat your information a lot. So this is a way to help optimize that in two different ways. One, to help understand and provide an intelligent chatbot functionality, which can integrate into your back office system and pull a lot of data from your own systems to make it much more intelligent. The second way is to provide a phone chat agent, which is essentially a virtual agent, which will respond, be able to do the same thing as you could with a chatbot, but it's using our text-to-speech API. So it essentially provides that. And then our dialog flow, if you work with that at all, this is essentially kind of like the Google Home style type of back and forth using speech and then honing in a specific intention that a user may had via voice. And then there's a whole framework that's provided by dialog flow. So if we think about this as a business problem, the problem is these conversations that you have with the contact centers really aren't that great, and they're not great for the user, but they're also not that great for the company as well. So they often don't provide a great outcome, or they require a human to get on the phone and speak with you, what otherwise might be a relatively straightforward or otherwise kind of a mundane type of question. So in order to enable a better kind of conversation, there's really three main components, which you see here: the perceive, talk, and interact. The perceive is really our speech to text. You need to be able to take the audio that you hear and convert that into text reliably. In order to be able to respond to that, you also need to be able to take that text that you get back from your back office systems or your intentions in dialog flow and be able to respond to that user in a verbal way. And so that is our text-to-speech API, and that's how we provide that. And the last one is sort of the whole framework around how you have an interaction with via voice or via chatbot. And that whole framework of doing so. And that's what our dialogue product does. So the main components of where this contact center API fits in are essentially what I kind of described here as the customer, either phone or chat. So this is, again, the voice or chat. And typically where this fits in is where those individual users are routed into a customer contact center. Customers have a lot of different, or users and companies have a lot of different types of solutions that they use here across a wide range. There could be IVR systems. They could be, there's many different systems that are offered by many different companies. But essentially, they all have hooks into third parties and external systems to allow them to integrate, because that's how the call centers typically work. So where the contact center AI for Google Cloud fits in is essentially right here with the contact interface. So we provide an API that allows you to call and respond. And two main functionalities: the virtual agent. So this is the voice component of this. So I talked about having the text to speech, being able to respond in an intelligent way and using dialog flow to go back and forth and be able to answer the questions within the context of the conversation that you're having, versus just be able to answer the specific context with the answer without any real context. So that's the big difference here. And something that's kind of interesting here is agent assist, and this is even if you do end up with a live user, and as a part of the virtual agent, we have this capability which will be in the background and essentially be listening to the conversation. And as the customer or the caller in, maybe you, asks those questions, it will automatically go out to a knowledge base or any third, whatever type of system that you may have to look up information. And what's really cool about that is that as the user may be asking questions, the agent assist will be pulling up information from the knowledge base, from the help center, etc., and pulling that up there for the agent so they can be better able to answer the types of questions you're asking. It's a really pretty cool feature. And then on what you see here is the backend fulfillment. This is the integration with a lot of third-party systems or your organization systems. So this could be their account system. You want to look up the account, look up the hours for the individual location. There's a whole series of different APIs you can imagine that would be available that could be exposed. And if you are essentially your knowledge base as well. So if you're looking for information within the context of commonly asked questions, this is a great way to integrate this into the contact center API. Okay, so I think we talked through this. I mentioned we have a lot of technology partners, and the reason that we have partners here is because these are typically things that companies already use, and the way that this is kind of understood is a way to drive intelligence into this, or be able to bring the data you already have in your organization into the conversation here. Okay, so the virtual agent is the text-to-speech bit, and so it uses the same API, same style API as the speech-to-text, in the sense that you send an audio file for the speech-to-text. You do the reverse, right? And so you can do things like send in your text. It will respond in a series of different languages. So there's 30 different languages, and some on the order of 180 different voices. So there's a lot of different components that are available there, which is pretty cool. The agent assist, that's what I talked about, being able to reach out to third-party systems and pull that back. And then we have a third part we're just working on now, the Insights API, which is essentially looking at all of your data that they're essentially generating by running the system, and being able to pull some metrics and pull trends out of that. So what does it actually look like if you're using this? The first part here is a customer call comes into a telephony center, and these are usually some of the partners you just saw on the previous slide. Cisco, this is typically like a SIP type of system, and then that gets routed into our cloud speech-to-text. And our speech-to-text can in real time take the streaming audio that you have and automatically return the text here. And in this case, it's going to use our dialogue flow. And the dialogue flow, as I told you before, is kind of the context of how do you have this conversation and back and forth. And you can develop the dialogue flow with the specific of your business case here. So in this case, you've got the virtual agent here. So again, if this is the audio component here, we will use the cloud text-to-speech to be able to respond directly to that user and stream that audio back to the call center. So essentially, the user's interacting with the IVR, but really it's loading this agent in dialogue flow, looking up some information, and then responding to that user with voice as well. The second part of that is the natural language understanding here. So this is building out what kind of context can you pull out of what the user is saying. So again, it's using the speech-to-text. It's taking that speech-to-text API and looking up the results of that in a database or other third-party, it could be within an organization, their accounts, et cetera, looking up that data and then responding back. And then you have the full session of transcripts of your speech-to-text. You can have the sort of the back and forth between that customer that you can use for training and additionals. So I think the key components of the platform and why this could be difficult in the future, or difficult if you didn't have this, is these components right here represent a pretty high barrier to actually providing this intelligence, right? So if you already had the data or the text, it wouldn't be that difficult to then go and build in the intelligence for that. But the APIs themselves provide a lot of value, make it really simple to be able to integrate. And so that's the whole point of this here. And so if you use our APIs, between the authentication, the developer experience, they're relatively straightforward, and compared to what you would need to build for a comparable type of architecture, you start way ahead. Though you have some limitations, as I mentioned before, about maybe domain specific. These models are models that we maintain as Google Cloud, and allows you to use them in a pretty straightforward manner, just like any other API, which is really the power of the platform here. And then the other component is the dialogue flow. In order to build something that has sort of a context and a conversational type of context, it takes a lot of effort to be able to do that. It's pretty straightforward to write if-then statements or to write switch statements as a part of your application to handle different components. but being able to have the context of the conversation and then use that later as you are answering questions or doing searches is something that really adds a lot of value. So if you were to develop that, it would certainly add a lot of time. So I think those are the three components that, as we built this solution, seem to add and offer a lot of flexibility, offer a lot of value to people as you use them as well. Again, it brings it back to the developer experience. So very quick example here from an architecture perspective, if any of you are interested in architecture, but generally the same type of flow. Customer, you have various channels that come in, and they'll come in either via chat or via voice, and this is how we fit in here. So nothing really want to highlight here other than we integrate with different partners here. All right. Okay. And this is the interesting thing about the insight. So if you have access to these conversations that you've been having or that your users have been having with your call center or your virtual agents, you can actually do something interesting over time, right? You can start to notice that all call centers do this. They keep track of metrics and then take actionable, measurable actions on that. So one of the things that we did is for the Insight API, it essentially provides a framework for you to hook into. And this is a very similar type of architecture that you saw from a serverless perspective. We used a whole set of serverless functions like cloud functions and our speech-to-text API. We also have a data loss prevention API. So as our chats flowed through here, we ran all of the chats through this particular flow. Again, as a serverless, and we stored that in BigQuery. And then we essentially expose BigQuery as our serverless data warehouse if you haven't worked with it before. So we use that as sort of the component, the data house component of that. And then we built a whole bunch of different dashboards using an app on top of App Engine. But the point here is that we're able to gain a lot of insights into like the durations of the calls, what types of calls they were, the percentage by which the automated or the agent was able to respond versus had to call in a human, the extent to which the customer rated it satisfactory afterwards, the number of engagement with chatbots versus in person or voice calls. So we were able to pull all of this together. And again, we built this. This is a pretty straightforward. It's an event-driven architecture as well. And it's also serverless. So it makes it really easy to be able to spin up and spin down and not worry about sort of the consumption or the ongoing costs. So that was also a pretty interesting component of that. So I think that's all I had to talk about today, mainly the two projects that I worked on from a serverless perspective, from an ML and AI developer perspective.